All right, welcome. In this video, we're going to be working some multiple choice with calculator practice, and this is the Release 2008 VC exam. So we're just going to be working section 1, part 2. And this one, I don't think this one's going to require a calculator, but just in case, I've got my calculator ready. It's in radian mode. I'm good to go. Okay. So the graph of f prime is shown above. The domain of f is the open interval 0 to d. Which of the following statements is true? F has a local minimum at x equals c. No, the derivative went from positive to negative. That's going to be a local maximum. F has a local maximum at x equals b. No, f prime has a local maximum at x equals b. F has a point of inflection at x equals a. Okay. No, at x equals a, f prime is changing from positive to negative, which means that, from negative to positive, which means that f is having a minimum there. Point of inflection at b and f of b, yes, that's going to be the right one. And I'll come back and say why that's true in a second. Concave up on the interval c to d, f prime is concave up, but f prime is also decreasing, which means that f is concave down. Okay, so point of inflection at b and f of b. All right, well here the derivative is increasing. That means the original function is concave up. Here the original function, the derivative is decreasing, which means the original function is concave down. Okay, so that's going to be my point of inflection. And we know that points of inflection on the graph of f correspond to extrema on the graph of f prime. Okay, so another reason. All right. Water pumped out of a lake at the rate of r of t cubic meters per minute. How much water is pumped? So the total amount is going to be the integral of the rate. So I'm just going to integrate from 0 to 5 r of t dt. Okay. And so I'll go over here. I will ask for an integral from 0 to 5. This is 12 square roots of, I'm going to put the fraction bar in so I can write it just like I'm saying it, t divided by t plus 1 dt, and then it's going to think for a second. Okay, 47.19. There it is. All right, the graph of a function f, which of the following values of c, does the limit of f equal 1? All right, here, yes, definitely. Looks like there, the limit's going to equal 1 because I'm approaching 1 from both sides. And this is not a place where the limit is 1 because I'm only approaching 1 from the left side, not from the right side. So, all right, I'm going to say probably -2, 0 only. Yeah, all right, that's going to be these. Let's see, what else? They're suggesting 3. Yeah, we said that's not going to be a place where the limit equals 1. All right, let f be positive, continuous, and decreasing. All right, so they're going to do the integral test, right? If the sum of a n converges to k, which of the following must be true? Okay, well, we know the series is bigger. Okay, so from 1 to infinity is going to be bigger than the integral from 1 to infinity of f of x dx. All right. All right, we didn't actually need the fact that the series is bigger because all we know, or all that we need to know, is that the integral converges, right? I know that it converges and it's a value that's less than k, but they didn't even get into that. They're just saying, okay, we know that it converges because the corresponding series converges. Okay. The derivative of f is given by f prime as x squared cosine x squared. How many points of inflection does the graph of f have? All right, so we're just going to be counting I'm just going to graph f prime. You could graph f double prime and look for the number of sign changes, but then that would require you to take the derivative either by hand or using the calculator. If you use the calculator to plot the derivative using math 8 inside of y1, it's just going to graph really slow, and that would be a waste of your time. So what we're going to do is we're going to type in x squared cosine of x squared. And on the open interval -2 to 2, I'm going to switch my window to only be looking from x equals -2 to x equals 2. I feel like -10 to 10 should probably be enough for y, but we'll see. All right, there's 1 point of inflection, 2, 3, 4, 5. Okay, this is kind of tough. I'm counting the direction changes in f prime, right? Extrema of f prime correspond to 2 points of inflection on f. So I'm going to go down there. I'm going to switch up the window. The y minimum -5 and the y maximum, I think 2 should be all right. 1, 2 extrema, a third extremum, a fourth extremum, a fifth extremum. Okay, so that's where I'm counting 1, 2, 3, 4, 5 direction changes. Extrema on the graph of f prime correspond to 2 points of inflection on the original. So I'm going to do that. Okay, let f and g be continuous functions on a closed interval. Okay, c is between a and b. This is kind of a lot. Okay, the integral from a to b of f is p. The integral from c back to b of f of x dx is q. Okay, I'm going to have to draw a diagram. I don't know if I've ever seen this problem before. I like it. I should be using it, I feel like, but let's see. All right. So I'm going to just kind of draw out a diagram. We're only talking about, oh no, I'm going to draw a diagram for f and a diagram for g. Okay, so this is going to be my x-axis. I'm going to label A, and C is between A and B. Oh, okay, so this isn't even a backwards one. Okay, so I'm going to say this is f. And so let's see, the integral from a to b of f of x dx is equal to p. Okay, so in total this area is p. Okay, but then the integral from c to b of f of x dx is q. Okay, so this would be, I guess, p minus q, right? Because if I was adding them together, it needs to add up to p. Integral from a to b of g of x dx is r. I don't know, maybe I'll draw g to look a little different. Okay, a to b is going to be a total of r, and the integral from c of g of x dx is s. So this would be r minus s. Okay. Then the integral from a to c of f of x minus g of x, well, that would be the integral from a to c of f of x minus the integral from a to c of g of x. So this is going to be p minus q minus, okay, so that's the integral of f, is p minus q for a to c. Then minus the integral of g of x is going to be, from a to c, is going to be r minus s. Okay, so that's p minus q minus r plus s. Oh, that's a good one. Okay, so I need the two minuses in the middle. That's going to be this one. Yeah, I like that one a lot. Right, if the sum an diverges and an is smaller than bn, which of these statements must be true? Okay, before I even get into it, I know that if I'm saying, okay, if I've got a, they're going to ask about the sum of bn, and b's terms are bigger than a's terms, and a diverges, so I know that the sum of bn is diverging. In fact, I'm going to write that right now. Okay, I'm not sure about the alternating part because I'm pretty sure I could come up with a counterexample where I've got diverging, bn is greater. Yeah, I think, you know, harmonic, bn would be 1 over the square root of n. Yet this, it could go either way, right? This is what we know. Okay, we don't know much about the alternating series situation. Okay, what is the area enclosed by the curves of this and that? All right. Well, thank goodness we have a calculator, right? Because this is the type of problem that's really rough if you don't have one. So we're going to go over here, and we're going to plot x to the 3 minus 8x to the 2 plus 18x and minus 5. And then the other one is y equals x plus 5. Right? And I'm going to zoom to standard, zoom 6, so that I can hopefully see the whole thing. That's... Oh man. Alright, so it looks like we're going to have to zoom quite a bit out. Let's see if that does any better for us. Did I type this in wrong? Y equals x to the 3rd minus 8x to the 2. Okay, yeah, that'll make a difference, I bet. Yeah, there we go. Oh, so I wasn't even needing to zoom out all that much. Yeah. Yeah, I was thinking, usually the standard window does it, but all right. So we might need to go, I'm going to adjust the window one more time so that y goes from 0 to 20. And then I'm sure that this will be enough for me to see. Okay. Now, my next order of business is I need to find the exterior intersection points, because my idea is that I'm going to be integrating the absolute value of the difference in like y1 and y2, so that it's always positive, and I'm just getting, you know, the total amount of area. So I'm going to find the first intersection, blue, red, give it a guess, there. Okay, x equals 1, y equals 6. Then the second intersection is going to be blue, red, guess. I'll just scroll over there because it'll show the exact one I want, and that's x equals 5. So I'm just going to integrate the integral from 1 to 5 of the absolute value of the difference, and that will give me the positive number. So math 9, 1 to 5 of, I just recently learned that you can get absolute value out of f2. So I'll do y2 minus y1. You could do y1 minus y2, right? Because we're taking the absolute value, doesn't matter. And it's going to think for a second, and I'm going to get 11.833. Okay, there it is. I think I can get one more problem in before my class starts to come in. And okay, I bet you've done this problem recently. This looks like a type of problem I might use on a Taylor series test, and we just took one of those. So third degree Taylor polynomial, okay, it's going to be f of 3, remember we know the skeleton, plus f prime of 3, x minus 3. I got to think 3 terms. It should be enough for us to distinguish. I doubt any of these. Okay, I'm going to get rid of D and E because these are Maclaurin polynomials, and we want a Taylor polynomial around x equals 3. All right, so f of 3 is 2 minus x minus 3 plus, okay, we need to, oh, no, they've got 2 that are the same. Okay, well, but we'll be able to keep the pattern going. So 6 divided by 2 factorial is 3. Okay, so this one's out. Okay, now I've got it down to these 2, and so, okay, then, okay, the third power term is going to be, and maybe I should have looked and said, oh, all right, well, we can just determine just on the third power term, if you look at all of these being different, we could say, all right, well, I knew that the third power term is going to be f triple prime of 3 divided by 3 factorial times x minus 3 to the third. F triple prime is 12. 3 factorial is 3 times 2, so that's 12 divided by 6. It's going to be 2, right? So that's why I'm going to be choosing answer choice A here. Okay, number 85. Move my calculator during class. Let's see. 85 is a particle moves with velocity here. So that's in parametric mode. That's not a good sign. Okay, I'm not the one that put it in parametric mode. I think I loaned it out for somebody that was doing a practice AP exam, and we know that going into parametric mode is not really the way to go, pretty much ever in AP calculus. So the particle moves along the x-axis with velocity given by v equals something that we're going to graph. Okay, plus 9t minus 2. All right, great. How many times does the particle change direction as t increases from -3 to +3? Okay, so I'm going to graph this from -3 to 3, and I'm looking for, okay, a direction change is going to be a sign change in velocity, so I don't really need that much y, I just need to count the times it crosses the t-axis. 1, 2, just 2. All right, I don't usually recommend, well, I guess there wouldn't be a sign change there unless it did actually have a 0. I don't usually, that's what I'm saying, I don't recommend doing this, but I'm going to find the maximum between x equals 0 and x equals 1, and that is still where y is a negative number. So the velocity is still negative there, it's just very close to positive. And we're going to say, all right, it's got 2 direction changes because there were 2 sign changes in the graph of velocity. On the graph of y equals f of x, the slope at any point dy dx is twice the value of x. Okay, this is one of those old-fashioned Algebra 1 scenarios where we got to translate from English to algebra. The slope is equal to, is twice the value of x. Okay, f of 2 equals 3. Okay, well then, I mean, we know what y is if dy dx is 2x. Y is equal to x squared plus c. Right? So f of 2 is 3, so 3 equals 4 plus c. That means that y equals x squared minus 1. You could use a definite integral for this, but I just don't think that's the way to go when we could just say, oh man, we can just anti-differentiate that in our head. Okay, what's the value of f of 3? Well, that's going to be 9 minus 1 is 8. All right. Object traveling in a straight line has position x of t at time t. If the initial position is 2 and the velocity of the object is that, what is the position of the object at time t equals 3? We've got a calculator, so let's just go ahead and do that. I'll write down what we need. The position at 3 is going to be equal to the position at 0 plus the accumulation of some sort of rate of change, like x prime, which is velocity. Okay, so I'm going to be typing in 2 plus the integral from 0 to 3 of that. Cubed root. Okay, now I know that cube root is somewhere in there. It might even be an f2 or something. Yeah, there's the nth root there. But maybe you don't have f2 on your calculator, right? Maybe you're working with a TID 3. And I think the way to go in that case is to use parentheses, 1 plus t squared. And then we're going to take that instead of, the cubed root is the 1/3 power. So I'm going to take it to that 1/3 power, dx, and let it think, 6.511. Okay. All right. The continuous function f is positive and decreasing. G is the integral from 2 to x of f of t dt. The following could be a table of values for g. Huh. Okay. Well, let's draw a picture. All values of x, the continuous function f is positive and decreasing. So I know it's above the x-axis. Okay, f is, I don't know, continuous, positive, and decreasing. You would think they were going to ask you a question about the integral test, but I know they already asked us a question about the integral test in this exact section, so I'm not really sure what's going on here. Anyway, okay, I've got this. Oh, okay, so from 2 to x. Okay, so, I see what we're saying, because it's all these tables start where x equals 1. Okay, we need to be seeing, if that's 1, we need to be seeing a negative value because I'm integrating backwards on a positive function. Okay, so C is out, D is out, and E is out because I know if I integrate from 2 to 1 on a positive function, it's got to be a negative number. All right, at 2, it's got to be 0 because it's the integral from 2 to 2. Okay, but that didn't help me at all. And then at x equals 3, I need to be integrating from 2 up to 3, and that's going to be a positive number because the function f is positive. So, this one's tricky. I want you to think about, what's the difference in these? Because these are both positive numbers. Okay, I'm thinking that that's where the decreasing comes in. Okay, so I might need to draw this again on a different slip of paper so that you can see what I'm saying. Because if I tried to go off of that one, it might not work. All right, so I'll do this a little smarter here. 1, 2, and 3. Okay, f is decreasing while being continuous and positive. Okay, well, the amount over here of area underneath the graph of f between 1 and 2 has to be more than the amount of area under the graph of f between 2 and 3, right? Like if I called this region A, I called this one region B, I know that A is bigger than B. So, as a result, okay, if that's just the area, I know that g of 2 equals negative A, and I know that g of 3, oh wait, no, g of 1 is negative A, because I got to integrate from 2 back to 1. G of 2 we know is 0. Okay, g of 3 is going to equal positive B, but I know that the actual size of the number B is going to be less than the size of the number A, so I need to have that happening, and that's why it's going to be A, right? This would be if the function was increasing, right? Then I would see a bigger area for B, and this number would be bigger than that one was, negative. Okay, so this is why this one's A. That one's a little tricky, okay? But again, if you see what they're wanting you to see, then it's not so bad. Okay, f is continuous on the interval negative 2 to 2. F of negative 2 equals f of 2, which is equal to 0. If there is no c between negative 2 and 2 where f prime of c is 0, which the following statements must be true. All right, here's what they're getting at. Remember, mean value theorem, Rolle's theorem, is that if the function stays constant, or appears to stay constant on an interval, and it's differentiable, then that means that you've got at least one place with flat tangent, with f prime equaling 0, right? So if I went like that, right, as long as it's smooth, I'm going to have that. But if it says if there's no c for which f prime equals 0, probably what we've got is another, I'll draw a different scenario in red, is, okay, if I want to go back down here without putting in a flat tangent, well, I'd have to have a sharp corner. So I'm going to say that f prime fails to exist at some point, right? For some k, f prime of k does not exist. Okay, so that's going to be answer choice E. Okay, f prime exists, but f prime is not continuous. That is exceedingly rare. Okay, I think you need to know that it's possible, and I don't even have it at the top of my mind. I could go back and look at my emails, because one time there was a big discussion on this in my class, and I emailed somebody who'd been teaching AP Calculus for a really long time, and she sent me an example, and well, it wasn't exactly a function we see all that commonly. It was defined piecewise, and the derivative did exist, but the derivative was not continuous, but kind of because of like oscillation or something. It was very weird. So moral of the story is you need to know that f prime existing but not being continuous is possible, but not actually like realistic. Okay, not something you're going to have to deal with just to maybe to know it was possible. All right. 90. Okay. This isn't the last problem, is it? Oh yeah, there's two more. I was like, this is all they got, and they got a chain rule problem for me. That's going to be their most challenging item. I was not impressed. Okay, so what is the slope of the graph of h at x equals 2? Okay, that's going to be h prime of x. Okay, now we're going to need to, administer the chain rule here. So we're going to take the derivative of the outside while leaving the inside the same, and then multiply by the derivative of the inside. Okay, so h prime of 2 is going to be f prime of g of 2 is -1 times g prime of 2. G prime of 2 is 2. So I've got something times 2. F prime of -1 is 3. That's why it's going to be positive 6 there. I feel like I must have just exchanged some problems, because I have to look at the actual released exam, because I can't imagine they would give you a table chain rule problem here on number 90, and on number 92 they would turn right around and give you a graph chain rule problem. I'm just a little suspicious of this, but I'll go look it up, I guess. So 91, let f be the function given by the integral from 1/3 to x of cosine of 1 over t squared dt between x's 1/3 and 1. Where is f going to have a relative maximum? Okay, well, we want to be able to graph the derivative, and we don't know where this thing equals. I guess we could say basically where 1 over t squared was equal to pi over 2, I think. Anyway, easier to just write, all right, f prime of x, we can say that real quick. We're going to take the x and we're going to throw it in wherever we see t. So that's cosine of 1 over x squared. Okay, we can graph this without too much difficulty, right, on 1/3 to 1. So I'm going to set the window. Okay, cosine of 1 over x squared. That's I don't know. I get a little skittish about when you've got a denominator with more complicated stuff in it. X squared. Okay, I'm interested in this between x equals 1 divided by 3 and 1. And let's see, have a relative maximum. I'm just looking for where this goes from positive to negative, so I don't need that much in the y direction. There. Okay, there it was. It's that 0 right there. So I'm going to calculate a 0. It looks like, I don't know, I'm going to have to scroll because I don't know where I'm at. 0.461. And there it is. Okay. And then one more is this other chain rule question. So b of x is g of x f of x. What is b prime of -3? g prime of f of x times f prime for the chain rule. Okay, g prime of f of negative 3. Okay, what is f of negative 3? This is y equals f of x. That's 1. Okay, g prime of 1. And then times f prime. Well, f prime is always 1/3. Okay, g prime at 1 tangent at x equals negative 3 and x equals 1. Okay, so am I missing something here? Like, okay, at x equals 1, I'm just missing something here. Because it doesn't go through, oh, and you can't even see what I'm, pardon me, hopefully you're just looking on your own copy. It doesn't go through grid intersection points. I feel, okay, maybe what you're supposed to see is that this is a little bit below that grid point, and this one's a little bit below that point. I'm going to just say the slope is -1/2. Yeah, and so I'm going to say it's -1/2 times positive 1/3, which is, you know, one of my answer choices. It's a little weird. We would definitely prefer if this was going through grid intersection points so we could know for sure that we were doing it right. But that's going to be all the problems for this section. Thanks for watching.